Graphing rational functions by hand. The following are the things I use to graph rational functions by hand. Sometimes I use all of them, sometimes I leave off the x and y intercepts, other times I find other points, but generally speaking, these are the things that I use to graph a rational function by hand. I use the parent function y equals 1 over x, which, if you recall, looks like this. If I'm going to draw the graph y equals negative 1 over x, I can just flip that one over the x-axis. And the reason I use this parent function is because rational functions, even when they look more complicated, really want to imitate these graphs around my asymptotes. Either 1 over x or negative 1 over x. And notice kind of the pattern that they have across from each other in this diagonal fashion. We'll come back to that in just a bit. I also like to use vertical asymptotes and horizontal asymptotes, kind of to start, holes if there are any, and sometimes x and y intercepts. Let's see how we do this. Consider the function f of x equals x squared minus 2x minus 8 over x squared plus 2x minus 3. Going to go ahead and factor both the numerator and the denominator, giving me x plus 2 times x minus 4 over x plus 3 times x minus 1. I'm going to start drawing my graph, and I will use my vertical asymptotes and horizontal asymptote as guides. So I have a vertical asymptote at x equals negative 3. Another vertical asymptote at x equals 1. There are no holes, no removable discontinuities. And then to find the horizontal, that's when we let x go to infinity, and all I really care about are my highest powers and their coefficients top and bottom. So if I take the highest powers top and bottom with the coefficients and simplify, I get 1, which is my horizontal asymptote, more specifically y equals 1. Now, what I like to do is pick any x value to the far right of my rightmost vertical asymptote. Any x value will do, and find its corresponding y value. And I like to find one, that is, choose one x value to the far left of my leftmost vertical asymptote, and find its y value. Well, let's start by picking any x value greater than x equals 1. And I'm going to choose x equals 4. We'll see why I chose that in a little bit later. But if I choose x equals 4, and I want to find f of 4, I get 6 times 0 over 7 times 3, which is 0. So I know that the graph goes to the point 4, 0. Now let's choose any x value to the left of x equals negative 3. So I'm going to choose x equals negative 4. And I'm going to find f of negative 4. So I'm going to plug this in again. I like to plug things into factored form usually. So I get negative 4 plus 2 times negative 4 minus 4 over negative 4 plus 3 times negative 4 minus 1, giving us 16 over 5. So when x is negative 4, y is 16 over 5. So somewhere about right there. Now, why do I do this? And here's the reason why. Recall that my function, my rational function, as complicated as it might look, wants to look like either 1 over x or negative 1 over x. So if I have this point over here at 4, 0, and use my asymptotes as guides, I know that the graph will look like that. Furthermore, I know what it will look like across from it, because it really wants to look like one of these graphs. So it's going to look something like this. How about this point over here when x is negative 4? Well, similarly, I can use my asymptotes as guides to give me that portion. Using my parent functions, I know what it will look like across, that is diagonally across the asymptotes. And it's going to look like this. And all I really got to do is connect my graphs. I'm not looking for perfection, generally speaking. I'm just looking for a decent representation of the graph. So the graph will look sort of like this, pretty close to this. I'm going to add in the x-intercepts as well. Now I already have one of the x-intercepts when y equals 0. I already have it here. It's one of the points I chose. So to find the other one, or if I hadn't found the first one, I want to set f of x equal to 0, which is where the numerator equals 0, right? The entire function is 0 when the top is 0 and the bottom is not also 0. So I have my x-intercepts at 4, 0 and negative 2, 0. So right about there. And the y-intercept when x equals 0, and this is one of the times when I plug into the non-factored form, because it's pretty easy to determine f of 0. Everything is 0 except for the parts that don't have an x, so I get 0, comma, 8/3. And let's do one more example, just so we can see the process one more time. Let's look at g of x, which equals x squared plus 8x plus 15 over 2 times x squared plus 2x minus 8. Let's go in and factor these two. I get x plus 3 over times x plus 5 over 2 times x plus 4 times x minus 2. There are no holes, no removable discontinuities. We do have 2 vertical asymptotes. One at x equals negative 4 and one at x equals 2. We have the horizontal asymptote at y equals 1/2. Let's go ahead and find our let's do our y-intercept when x equals 0. And we get negative 15 over 8 by plugging into g of x over here. So when x equals 0, y is negative 15 over 8, so something like that. And let's find our x-intercepts when y equals 0. That is when the entire thing is 0 or the top is 0. So we have at negative 3 and negative 5. And let's find one more point, because I already have a point to the left of my leftmost vertical asymptote. And let's find any value of x to the right of my rightmost vertical asymptote. So let's try, say, x equals 3. So when x equals 3, we get y equals, and I'll plug into the factored form, I get 6 times 8 over 2 times 7 times 1. Which is 48 over 14, which is a little bit bigger than 3. So let's plot that point. I get 3 and then something over here. And let's start graphing the outer parts. My graph is trying to imitate 1 over x or negative 1 over x. So that part must look like this. And then across from it, it must look like this. Let's use this point to the left of my farthest left vertical asymptote. Again, it's trying to imitate either 1 over x or negative 1 over x. So right across from it, it must look like this. And then all I have to do is connect the dots. And one thing I recommend is that even if you have to graph by hand, go back and plug both of these into your calculator. I recommend Desmos. And see, did you get the graphs correct?